We are now going to do hypothesis tests for small samples. So just like confidence intervals, we did it for large samples, now we're going to do it for small samples. So the condition here, this is hypothesis testing where sigma is unknown and n is less than 30. So normally sigma is unknown, and we end up using s in place of sigma. So the important condition here is that n is less than 30, and that means it's a small sample. Okay, anything less than 30 we're going to consider a small sample. So let's go ahead and see what we do here. You could maybe almost even guess how this is going to change. It doesn't change very much. It's pretty much the same procedure, except we're going to use a critical t-value when we determine the rejection region. Okay, so in this case, a college bookstore claims the average price of their textbooks is $75. So to test the claims, a sample of 15 textbooks is taken and has a mean of $78.95. The standard deviation of the sample is $7.42. Test at alpha equals 0.01 whether the true mean price is greater than $75. Okay, so the hypothesized mean is this $75. Okay, we don't know what the true mean price is, but the bookstore claims that it's $75, and we want to test to see if maybe the true mean is greater than 75. So the null says the true mean is equal to the hypothesized mean. There's no difference. It's the same. And the alternative is no, I think that the true mean is greater than 75. So that means this is a right-tailed test. So I'm going to draw my rejection region, and this is going to be my critical value here. So now what changes here? So the only thing different between this test and a normal hypothesis test is that the sample is less than 30. Okay, in this case there's only 15 books in the sample. Okay, so what I'm going to do is I'm going to find my degree of freedom, and the degree of freedom is going to be n minus 1, just like for the confidence intervals. And then my alpha is 0.01. So this is a one-tailed alpha with 14 degrees of freedom. And so I'm going to go to my t-table here. I'm going to do one-tailed alpha, 0.01, and then 14 degrees of freedom. So instead of going to the bottom, I'm going to go to 14, and I get this critical value. This critical t-value. It's 2.624. So this is 2.624. Okay, so that's a critical t-value, and it's a little bit bigger than the critical z-value. Okay, the critical z-value for that would have been 2.326. So what you're really doing is you're requiring a little more evidence in order to reject, which makes sense because you have a smaller sample. Okay, so now over here is the reject H0. So calculate the test statistic. If it's greater than that, you reject H0. So the test statistic is pretty much the same. Okay, x bar minus mu. The only difference here is that the theory is now based off of S. So you're not using S in place of sigma. You actually are supposed to use S. Okay, so for this example, we have 78.95 minus 75 divided by the standard deviation, 7.42, over the square root of n, so the square root of 15. So it's the exact same as before. So 78.95 minus 75, and then divide that by 7.42 over the square root of 15. And I get 2.06. And comparing this back here, that does not lie in the rejection region. So what we're going to do is fail to reject H0. Which means there is not enough evidence to conclude true mean is greater than $75. Okay, so we don't have enough evidence to say that the bookstore's claims are not true. Okay, at least at this significance level, and that is a pretty high significance level. So possibly if we change to 0.05, we would have enough evidence, right? Okay, so really nothing changes here, except for the degree of freedom, n-1 degrees of freedom, and this is a critical t-value. Okay, that's really the only difference, and then you perform the test like normal. So what we need to do then is we're going to, just like with confidence intervals, we're going to do hypothesis tests where we have to calculate the mean and standard deviation on our own before performing the test. And so I'm going to go ahead and do one in the next video, and in the following video I'm going to give you one to do. Okay, so let's give that a try.